Okay, everybody, let's start our keynote lecture of today, which is going to be given by Erik, who is a major contributor to Astropy. And by major, I mean he's #1. And you have, over the years, you've already added 141,000 lines of code to Astropy, of which, of which 62,000 have been removed. But Erik, if you go to GitHub, the Astropy repository, you click on the button that says contributors. You get a list of like people's history of contributing, and Erik is like a solid #1, along with many other like the top 5 or so is here today, and they're all awesome. Thank you very much for your contributions, and I look forward to hear an update on Astropy.
Sounds good. Thanks, Geert, and thanks to all the organizers for putting this conference together and letting us all meet and see things face to face. One other thing I should mention, right? If you're interested in this beautiful clothing I've got here, fashion.astropy.org. Any of you can have this. All right, moving on. You can decide whether that's really important or not. So I'm here to talk today about Astropy, of course. This is a great audience to talk to about Astropy because I don't have to lead off by asking, has anyone heard of Astropy? Which is what usually happens when I give an Astropy talk. But no, in fact, I'm guessing all of you have at least heard of it, if nothing else, from this title and from earlier in the conference yesterday. And I just want to give you a sense of sort of where things are going right now. And since any good title to a talk has to have a subtitle, really once I thought about it for a while, it was mostly this, right? A few updates and mostly just random thoughts I have about how Astropy progressed, how we develop it, and what that means for hopefully other projects. All right, so we'll start with the origin story of Astropy, right? How Astropy came to be, because many of you here probably don't know the backstory. So it starts way back in the year 1900 and 111, right? when you could ask this question, right? Just a simple question that many people need to do for their day-to-day science, and the answer was, well, you can use that or 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 that. Right? There were 10 different ways to do very standard coordinate transformations, all of which were somewhat different, right? So you had to write whatever code you wanted to do your science. You either had to look through what all of the things these did and decide in advance whether or not it would do what you needed to do in the future, and decide whether you like the interface or not. So you had to decide that at the beginning, right? So that's really annoying. And on top of that, this is clearly representing a lot of just wasted effort, right? 10 different people did 10 versions of almost exactly the same thing, right? So this was a problem. This was a problem that a lot of people recognized. But it was this I think was this catalyzing email. So this was a message that went out on the Astropy mailing list, which predates the Astropy project by some 10 years. Just what it says right up there, right? This question had been asked before, but for some reason this particular post led to a bunch of people agreeing, yeah, do we really need to do that? That's not good. Let's do something about it. And I would emphasize that I think this is a crucial aspect. None of this would have ever happened if there hadn't sort of been a critical mass of people on the mailing list and in the wider community, the Python and astronomy community, that agreed something needed to be done. Right? This was not someone walked in and said, we should do Astropy, and a bunch of people were like, oh yeah, that's a good idea. Everybody agreed it was a good idea. Right? Everybody wanted a solution to this problem from the beginning. So that's why it led to sort of a grassroots discussion, right? And I mean that in a very literal sense, where just the people on the mailing list started saying, well, how can we fix this, right? We ended up putting together a bunch of votes on a really weird platform that I can't even remember how we managed to get it to work. That was really annoying to deal with after the fact. But nevertheless, we put together a series of votes that got 100 people, which really mostly served to convince us that it was worth putting some effort into making this happen. And the result was the Astropy you sort of see today. I think it's also kind of interesting to look back at the original vision, which we've got on the documentation for the project, and compare to what Astropy looks like today. And it's actually really close. We've actually stayed true to that vision, for good or for ill, I guess. But the point is, this is how it happened, right? It was truly very grassroots in that a bunch of people just said, we've got a problem, we need to solve it. Let's try to figure out how to solve it. All right, so that's sort of how it began. Now, before I go any further, I want to just spend a moment to make a distinction that I think a lot of people don't quite recognize. about Astropy. So Astropy is actually two different things, right? So it's the Astropy project and the Astropy package, right? So the project is the larger thing. So the package itself is perhaps properly called the Astropy core package, or at least that's what we called it at the beginning. And it's this actual code that's in the code repository, the thing you get when you download Astropy. The project is a much larger effort. So the project includes the package, but it also includes all of the different affiliated packages. So if you're not sure exactly what that is, I'll talk quite a bit more about that later. And I think more important is the community, right? So that means, in some sense, probably all of you here at this meeting. The community that agrees that it's bad to have 10 different packages that do the same thing, and that we should all work together to try to, get the most out of this community that we have built around building Python code for astronomy. Right, and the project itself is led just as the packages by the coordinating committee, right, which is not intended to be, a draconian dictatorship, but rather a coordinating committee, right, a group of people who, when there's an argument that can't seem to be resolved, we step in to try to resolve it. We deal with a lot of the crap, like keep making sure the website is still up. But it's supposed to be a community project, right? Not a top-down or run project. And that's to me is the other key philosophy behind both the project and the package, actually, right? That it's a community effort. That the whole thing is driven by and for the community, right? And this is what this means to me now. I can't necessarily speak for Perry or Tom or anyone else here, but this is to me the essence of what's really important and the thing I try to keep in mind whenever doing anything really to do with Astropy, either for my own work or developing it. So what I mean by is simply that professional astronomers, many of you in this room and many people in other places, at least help to write it, right? So it has to be by the astronomers because that keeps the connection intact for how we can make it for the astronomers, right? So it has to be the sort of thing that you can use in your day-to-day work if you're an astronomer, right? You don't have to be even a professional astronomer to use it, but that's sort of the target market, right? That's the community we're talking about. And it should be, so the for aspect is simply that it should just be usable to them, right? So that's really why it's crucial that it be by the community, is that's, in my experience, the only way to really make sure it's familiar and natural and usable very easily by the actual members of the community. Of course, that's not all there is to it. It's not just it should be familiar, it should be for the community. It's also meant to solve a slightly different problem, which XKCD very well explained, I think, just last week. I'll give you a second to process this one. Right? We all probably know this problem. We've all encountered this problem. We all know people who wrote code, didn't even learn to write code. They just started learning code on their own, and the code ended up something that is a mess when someone goes and looks at it who is experienced with writing code, and that's fine, right? This is not a problem in and of itself. We just need to figure out how to move beyond that, right? We want a world where code is both easy to write and easy to use. So one of the additional goals I see in Astropy is simply to make code that we can all see how it can be done more easily, right? So this is the secondary philosophy, is that it's not just supposed to be for the community, it's also supposed to help make the community better, right? Help us learn how to write better code and come up with new ideas for how the code can be more easily used. Which I should emphasize also is not just a matter of writing code for ourselves or with ourselves, right? It's also crucial to collaborate with people who are more software oriented, right? Like the folks here, many of the folks here from Space Telescope who may have software backgrounds and are not astronomers per se, but are crucial to the whole endeavor, right? We need to be learning more from them as professional astronomers as a part of this process of integrating new ways of doing things into Astropy.
Hey, Erik.
Yeah.
Rubbing against your microphone.
Oh, is that what's happening?
With your sleeve.
Maybe I should just do away with this. Can people hear me in the back, even without the microphone? Yeah. Can I just do away with this? Does anyone?
You won't be recording. Yeah.
This is the recording one, right? There's a different microphone for the recording. There, problem solved. All right, where was I? Oh yeah, right. Rambling. That's what I was on. All right. So now I'm going to move on to a little bit of a discussion about what's in Astropy, because many of you know what's in Astropy, but some of you don't, right? So I want to spend a little bit of time going over some of the key elements that are in there. Of course, the best place to look is always this. So I will not be offended if you ignore the next few minutes of my presentation and just browse the documentation. Feel free to do that right now. But I'll spend just a little bit of time overviewing what's in there, right? So these are sort of the key pieces that are in Astropy. So I'm particularly enamored in my day-to-day work with the units and quantities framework, right? So this is a way of just combining physical units with arrays and having them work just the way you would expect them to, right? When you divide an array in kilometers by an array in seconds, you get an array out that's in kilometers per second, and all of the units are taken care of for you, right? You don't have to worry about all that crap, because nobody wants to worry about that crap. And it's closely tied with a bunch of astrophysical appropriate constants, so you can do all of the things you might want to do when you write out an equation pretty much exactly the same way you would write it out, right? So you could actually write in code the same equations you would write in a paper. That's sort of the guiding principle behind this. There's the time module, right, which provides a standard way to represent dates and times. This is cheating in exactly how I phrase this, but in some sense, depending on the way you look at it, it's good to nanoseconds over Hubble time. Which is a neat thing to be able to say, even if it's not strictly true. It provides a bunch of utilities for working with celestial coordinates, right? That's critical. That in my mind is one of the key things that was extremely overduplicated before the package. So you can decide whether we just added one more package versus solve the problem, but that's up to you to decide. A lot of data structures and sort of bits and pieces to deal with image analysis, which of course is very important in astronomy. World coordinate systems, various forms of I/O, table manipulation, right? That's important. It turns out, again, in my day-to-day work at least, this is one of the most important modules simply because astronomers are terrible about table formats, right? There are probably 30 different kinds of ASCII tables out there that you have to read over the course of a month. And this combination of ways of reading it and putting it all in the same form, I think at least for me, has been crucial to smoothing my workflow. Another thing important for my particular work is cosmology, right? I do near-field cosmology, so it's nice to have those sort of things right at my fingertips. A variety of convenience functions for astrostatistics. I saw someone wants to do an unconference session about that, so hopefully there will be more in the near future. A package that's been sort of under development lately, but is going on, improving now, I think, is the modeling package. So that's just fitting data to models, or fitting models to data, sorry. But maybe both, depending on your attitude. But some form of fitting anyway. And of course, there's a lot of deep plumbing to make it all fit together and work, as well as it does, right? Is essentially what it amounts to. And this is one of those areas where I really think it's been crucial to have the support of software people, right? This sort of deep plumbing is something that astronomers just, no matter how much they try, they aren't willing to spend the time making this happen, right? This sort of deep plumbing and getting everything to hook together. That is an area where it would not have been successful without the work of the software developers, the key ones of whom are in this room actually right now. Question over there?
Can I just throw something in? Also, on that last note, very underappreciated, the astropy.utils package. Lots of really nice stuff in there, like color printing, progress bars.
That's true. That's true, right? That's part of this plumbing that I'm talking about, which you are all welcome to use, right? It's in some sense part of the public API. It's just generally speaking less well documented because a lot of it is sort of, I think that's fair. But there's a ton of useful stuff there, right? If you want to go and look in the documentation, it is all documented, just not quite as clearly as some of the parts that are more astro-specific. Right, any questions about any of this before I go on? Yeah, and interrupt me at any time, right? So that's the key thing about a rambling talk, is that you should stop me if I'm rambling too much. All right. So let me just talk specifically about what were important events in the last release, which happened in February. I think that's right. version 1.0, right? So the big thing that sounds big about that is that it's version 1.0. That doesn't really mean as much as it might seem like. It's a psychological milestone, certainly. And the other thing it means is what we call a long-term support release. So the basic idea is if you run an observatory, or you don't have to run it, but if you're part of an observatory, you might decide that you really only you don't want to adopt something that you know is going to change every 6 months, which is roughly speaking a release cycle. So if that's true, you can use only version 1.0 because we promised that will be supported at least in a bug fix capacity for 2 years at least. And that's usually enough time to shake out any major bugs. Not always, but and it might be even longer if it becomes important. But the idea is just this is a promise that if you're going to use it at an institutional level, this one will probably be more supported for a longer period of time than the ones that are not a something 0.0 release. So there'll be one of these every 4 releases of Astropy, so every 2 years is the idea. But this is the first one that has that label. Another big thing that changed in 1.0 is there's now complete support for going all the way from your celestial coordinate system of choice down to alt-as at a particular location on the Earth, right? This is very important for a lot of astronomy applications, of course. Lets you make plots like this. I was showing a few people yesterday, standard sort of air mass plots with what time the sun is setting and rising, right? The things you really need to know if you're going to observe something. There's been huge improvements to the speed at which table I/O happens, right? So we're basically at the same speed it would be if you read an ASCII table from C, right? I think that's fair to say.
Close. It's at least as fast as Pandas.
Right.
So it's state of the art.
Yeah, basically. Can't really do much better in Python. And I don't think you can do too much better, even if you just did all your work hard-coded in Fortran, let's say. The modeling package, I would say, has reached a point where it's ready for general use. There will still be enhancements going on, but in the past there was sort of a warning that, well, maybe you don't want to use this unless it might, we might make changes. It might be backwards incompatible. But I would describe it as ready for prime time. There's also another addition to tables to allow them to be fancy things. Mix-in columns is the term we've been using, but it basically means you can do things like embed coordinates as columns in a table rather than just array and dec. You actually have coordinate objects or quantity objects or any of these sorts of things that are much easier to use in Python but are somewhat less easy to represent as an ASCII table or something like that. You can still embed them in the table itself. And of course, there's a lot of other smaller things that are not sort of big ticket bullet point items. 676 is the total number of issues that were closed aside from these, right? So a whole bunch of smaller changes, a whole bunch of smaller additions, but these are the big ones I want to mention. All right, now what will be big in the next version? As I said, we have roughly a 6-month release cycle, so the next one should be July or August, something like that. Of course, these all have question marks next to them because it's not out yet. And it depends somewhat on what all of you here and the rest of the development community decides they want to focus on. That's another aspect of the by and for the community, that the community is what decides what's important and what we're going to invest our interest in, or our efforts in. Some of the areas that seem to me, at least right now, to be likely to be significant. There's going to be improvements to this quantity module. So it's this idea of having sort of supporting magnitudes, for example, built in some sort of very natural way in the quantities package.
How close is that to being merged?
I think it requires people to look over it and decide whether it makes sense. I think it's basically functionally done. But that part I said is often the hardest part, right? Getting everyone to agree on how it should look is often a lot harder than the code is. Right, a few other things you can look more deeply in this on the website if you want. Maybe we'll see, depending on progress, we might support actual velocities and coordinates rather than just locations. It might be possible to have uncertainties both in quantities and modeling. This is part of a a possible Google Summer of Code project. We'll see whether that actually happens, but I certainly hope it will happen. But the key point here is really that you help decide what's coming up next, right? Everyone here has the opportunity to come talk to us or even work on it here in the next week. And the wider community is also what I mean by this you, right? Everyone who's involved in the project, who voices their opinion on the mailing list, to be honest, is probably one of the most important ways you can help make these decisions. Right? So I can't really tell you what's going to be in there. Maybe it'll be nothing, right? Maybe it'll be just bug fixes if we're all really lazy. I know I worry about that sometimes. But, any questions about this? What should be in 1.1? Even comments, rude remarks, insults? Those are fine too. You have an insult back there? No. All right, so Kelly talked about this, so I don't want to dwell on it too long. But how might you learn more about using any of these features in Astropy? Of course, one of the best ways right now for all of those of you here is just to talk to one of us, either any of the people who are some of the Astropy developers or Astropy users, for that matter, that are here are probably good resources. There's, of course, the Astropy mailing list, which, as I mentioned, I think is at this point it's starting to become confused. That is not actually Astropy, the project. Astropy is a name that existed. The mailing list existed 10 years, if not more, before the project existed. But it's still a great place to get to ask questions about the Astropy project, because many of us hang out there. There's the development mailing list, which is better for discussions, for example, saying what you think should be in 1.1. I should also plug the Facebook group that Tom created yesterday at Kelly's prompting. There's now a Python and Astronomy Facebook group that you're all welcome to join. Maybe that will be friendly, maybe not, but I hope, based on Kelly's comments, that it will be very friendly. We'll see.
I think we should all put forth an effort to collaboratively try to be sure that the tone of that group is different than the astronomers' Facebook group.
Agreed.
Yes.
I think we're all behind that.
Yes.
Yeah. For less interactive resources, the place I would direct you first, Kelly mentioned this also, right, is the Astropy tutorials website that has a growing list of tutorials that I hope will grow from contributions from folks here this week. And the somewhat more difficult, but still in many cases very readable elements are available in the actual documentation itself. All right, now I want to spend a little bit of time talking about what the practicalities of this by the community part mean, right? How does this process, right? Many of you are probably familiar with this, but I want to emphasize the things that I see as being the most important elements of how a community project like this that becomes very large can continue to operate despite being very large. But I should first start by saying how large, right? So these two plots here show you the number of commits that have been done in Astropy basically since the project's inception. And this is the number of individual people who contributed code, right? So this is now up to over 120, right? The version 1.0 release, I think, was 119, and it's now 125 or something like that. And that's remarkable, right? In, 3 years, practically speaking? Less than that. 2 years, we got most of them. We went from a core group of 5 or 10 people who were doing almost all the work to 120 different people out in the community contributing code. More importantly, although this actually, I worry about this when I give these sorts of talks, I always mention this, and that might not be true now since many of you are here in this room. But up until today, most of these people had never met each other face to face. They, in fact, met each other through the project, right? Through contributing code before they ever had any chance to talk to people in the real world, let's say. Right, so there was a segue here that I totally, I remember. Right, the key element here is that they all met each other through the internet, and of course we all know the internet is full of cats. And it turns out that's an important element to how they all met each other and how all of these people could contribute to the code. In that, it is an octocat that's particularly important, right? Through GitHub, right? For probably most of you are familiar, perhaps many intimately, with GitHub and how you use GitHub, but I think it's important to dwell on some of the things that are particularly important for Astropy, right? So GitHub allows any random person anywhere on the internet, anywhere in the world, to decide they want to contribute to Astropy. They can pull down the code, right, with sort of varying levels of difficulty depending on exactly how you want to do it. But they can pull down the code and they can say, I want to make this change to Astropy. And nobody has to say, oh, I don't know if I'm going to send you a copy of the code. Are you worth it or not, right? Any random person can just go on the internet and download the code and say, here's something I think you should do in Astropy. And in fact, random people sometimes do, right? For good or for ill. Sometimes it's both, right? But that's a key element here, I think, for why you can grow a project like this with a community just sort of spontaneously almost, is that there's no vetting process at the beginning, right? The barrier to entry is extremely low relative to what it was before something like GitHub existed. So any random person who's never been involved in the project before can just say, I want to make this change. Right? Then it creates a thing on the website. That thing does a number of different tasks that makes the whole process easier. The first and perhaps most important one that I'll talk about in a little bit more detail in a minute is that it runs a bunch of tests. So it makes sure this random person on the internet didn't just break all of Astropy. That's important, right? We don't want to do that. But then it also allows a way for people to provide feedback, right? Anytime some random person on the internet decides they want to contribute to Astropy, sometimes it'll be good, sometimes it won't be. But there's nothing wrong with the second one. You just have someone tell you, oh, this isn't quite what we had in mind. Maybe you should do this instead. So they can do that, leave all kinds of comments with even pretty sort of inline comments where you just say, oh, this one little thing you did, maybe you should fix that. Right, so it's very easy to leave those comments, in just minutes, less than minutes. And then the random person on the internet can just say, oh, you're right, I should have done that. They can send a new fix up, they can send up a new commit, and it appears right there on the same website. You can have more comments, and you can just keep iterating until the code is exactly the way everybody wants it. And then all someone who's actually one of the core developers with commit rights has to do is hit a big green button that says merge. Right? So every one of those steps is relatively straightforward and is all done via one interface that you can just work with through sort of standard web browser sort of things. Right? So I think that is the first of the key elements that makes this possible. It's just that GitHub makes it very smooth for anyone, anywhere to contribute code to the project. Another element that actually has been critical to allowing this sort of development method is this testing process. Right? So we use a Python testing framework called py.test, but there's others. They're all kind of the same, where you just write functions that say, did this do the thing it's supposed to do? If yes, awesome. If not, throw an error, crap. More important for the perspective of sharing code is not actually that the tests exist in the first place, but that every time someone submits a pull request, the tests get run on this service called Travis. Right? So this is a company that, free of charge for open source projects, just runs all of the tests whenever anyone submits something once you've got everything set up. And then another company that will do it for Windows. And it just says, did everything work? Yes. If so, big green button. Did something not work? Oh, no, big red button. Don't hit the merge button. Something went wrong. Right? That's simple in concept. Of course, the devil is always in the details. But it's critical to this because otherwise, in fact, before we started doing this continuous integration, it was much harder to keep track of all of this because people would submit code, something would break, and someone would be like, oh, wait, what broke this? And it would take many times longer to figure out what was going on. Right? So we would never be able to keep up with 120 different people providing different changes if it wasn't for this immediate feedback. Wait, this worked, or wait, no, this didn't work. Right? So that's a crucial element. Another crucial element, now I think more so on the user end, is the documentation, right? And the tools that makes writing documentation easy. So in my view, this is actually by far the most important thing, because we've all seen code, many different codes by astronomers that is not well documented, right? Right. This is what most astronomy code looks like, is poorly documented. Sorry, this is not what most astronomy code looks like. Most astronomy code has some random ASCII file at the top that's like, this is the code that solves your problem with image subtraction. Figure out how to use it yourself. Right? Like that's what most documentation in astronomy looks like. The key here is that we have a set of tools, particularly Sphinx and a tool that hosts Sphinx documentation, called called Read the Docs that just puts it all, again, that automatically generates every time there's a new change sent to the repository and posts it up somewhere for everyone in the world to see. Right? So any documentation that is made is immediately generated, tested in the same way through Travis, and then appears on the web for immediate consumption. So that's useful because it gives immediate feedback. But even more important, I think, for making sure it actually happens is the critical element of Python called doc strings. So while you're writing the code, you can actually write the documentation. And we've developed a bunch of tools for connecting this together with this to give you something like that. And those tools are critical for allowing any random person on the internet to contribute and make it be useful, right? Because otherwise, they're more likely to just contribute it and be like, here's some code that does some stuff. I know how it works. That's good enough, right? That's how most astronomers work, let's be honest. But with just a little bit of extra effort, you can convince them to say, well, why don't you explain how it works just a little bit more at the same time as you're writing the code. If it's any more than that, they won't do it, right? Astronomers do not go back and redocument things, right? They just don't. That's a practical fact that I have learned the hard way, both myself and among other people. So this I think is possibly the most important element of Astropy, that we stick to a documentation standard and it actually generates something that you can read on the internet without too much effort. Right, so to recap, what I think are the crucial elements that Astropy has that has allowed it to quickly develop such a large contributor base is, of course, the thing I said at the beginning, that we all agreed it was a useful thing to have. But the tools that were important is that GitHub makes it easy for random people to contribute random things that may in fact be useful. We test everything as soon as it appears, essentially, both on the documentation side and on the code side. And documentation is, at least relatively speaking, easy to do, right? And easy translates to much more thorough than anything else, because the easier it is, the more likely people are to do it and explain something clearly, or at least as clearly as they're able. Now, a question for this can be later discussion or perhaps an unconference session is that I'm interested in, because I've had trouble with this personally, is can we adapt this sort of workflow to our sort of more normal or ordinary research situations? I think we should. I think this would make a lot of science a lot easier to do and better done. I'm not sure. I've had trouble doing this. I've had trouble convincing collaborators that, in fact, that having standards of some sort is worth doing, to be entirely honest. That they're much more comfortable just writing their code, sending it off, and saying, all right, I'll figure it out later if I need to. Question, comment back there?
I mean, I think writing documentation is, as people write, it's a lot of extra work.
Mm-hmm.
I mean, my impression is that I would disagree with you when I say that things are stronger than a lazy and developers are lazy. I mean, it's a lot of work to write good documentation, and then as you make changes to the code, update that documentation. So I completely agree it should be done. It's really important, but I think that's why people are doing it.
Yes, right. So it's not that. Yes, you're completely right that it's not that they don't want to do it. It's that they don't feel they need to do it. They don't feel it's an essential part of the whole process, right? And I think you're right that that's one of the critical problems here. That's why I can't convince my collaborators to do these things, is because they say, well, why should I do that? I have so many other things to do, right? That's basically your point. My contention is that it's worth it, right? But that's perhaps an entire separate talk or unconference session. But I do see your point. Kelly, you?
I think one of the major ways we can start to do this is actually via the refereeing process, because that's like we get to decide what we do as referees. And I think for me, at least in my head, the similar thing is basically uncertainties. You don't publish papers if you don't understand how they estimated their uncertainties, or if you think the way they estimated the uncertainties is misrepresenting. And I think that as part of the referee process, we can really say, like, it's great, your code needs to be on GitHub, and I want to see the documentation. So it's just the paper may or may not be published with that, but if that becomes a thing, like, nowadays we say, oh no, the referee, we're not going to be able to do this, the referee's going to do blah, blah, blah. If we put that same thing in our head, like, oh no, we're not going to be able to get it past the referee if we don't put our code on GitHub and if we don't have documentation, then it's going to become one of the difficult things. That's not easy, that's not straightforward, but we have to do it.
That's a fair point.
They're going to start complaining to editors if they start doing that. I agree,
They may complain. They may complain to the editors.
It sounds to me like we should have an unconference session about this.
Yeah.
5 minutes, okay. All right, now I want to take a second to talk about affiliated packages and what those are. Right, so this is the beauty of giving a talk on something you've written a lot of the material for. I can rip this directly from the website, and it's still my original material. Right. This is what an affiliated package is by sort of definition in some sense. But what's really relevant? What's really relevant is the idea behind this, right? That affiliated packages are something that is attached to the Astropy community and sort of shares the same ideas and standards that Astropy expects, right? And this is, of course, a moving target, right? Which is a little weird. It doesn't mean anything extremely solid, but it really means something very important simply because the people who are involved in it think it does, right? That's what it amounts to. So now I just want to give a quick overview of some of the affiliate packages that are out there. Actually, I won't go over these one at a time other than emphasize you're going to hear about at least a few more in some of the talks in the rest of this conference. And to just emphasize there's actually a bunch of them now, right? That it's not just a few like it was even just a year or two ago. That this is all of them so far, and it keeps growing. And so what's the thing that brings them all together? Well, they share this common goal and vision that I mentioned before, or at least many of them do, about reducing duplication of code and embracing new and better coding standards, right? Which includes documentation, testing, and all of these sorts of things. But the other thing that brings them together and that makes it easier to do all these things, I think, is the package template we've developed for this. So the package template is basically a ready-to-go copy of the stuff that's a lot of the plumbing, at least, that's behind Astropy. In particular, this thing called Astropy Helpers that has the documentation tools, the testing tools, and many of these sorts of things. And it allows any person who isn't particularly interested in details of how packaging works in Astropy to just grab this template, follow a step-by-step document that's rather long, but is at least step-by-step, that describes how to just put their science code into something that's a proper package. And so that's perhaps the key part, is that it just tells them how to do that and gives them all of the tools I described before about Astropy, so hopefully they can build their own community around their package. Now, does this work? Well, I feel like these quotes emphasize that it depends on who you ask. I like this one, right? That says this package template does exactly what it's supposed to do. But we get a variety of different responses, right? These are all conversations I actually had with people, right? This is a fair concern. It's not always easy to understand exactly what's going on. And some people just say, oh, why would you bother doing that, right? There are plenty of people with this attitude here. Not here, I should say, right? Probably none of them are at this conference, but it's important to recognize that there are many people that just don't see the value in this. And that's probably okay, right? I think Kelly made a very good point yesterday that it doesn't matter if some of these people exist, as long as enough of us agree that, in fact, this stuff does matter. Now I just want to spend...
The last one, what does that have to do with units? Like package template is for you, it's a thing that has documentation and testing already built in. I'm carefully emphasizing this on the basis of trying to disparage their character by saying that they don't know what they're talking about. But anyway, that was a joke. Anyway, don't want to go over time, so let me move on here. Now I do want to spend a second talking about some of the challenges Astropy is facing. I think one of them is embodied in this plot, which is the fraction of pull requests that are merged over time. This is thanks to Arfon Smith, who presented this at the last Astronomy meeting, which has been great at the beginning, right? 80 to 90% of all pull requests got submitted, and just recently this number has been going down almost entirely because it's hard to keep up with all the pull requests. Right? There's only so many people who have commit rights, and as more people are contributing, more of us need to look at the code and say, well, this random contribution, someone has to look at this random contribution, and I don't have enough time to keep up with it, right? Because I have to do other things too. This is a challenge I don't have an obvious solution for. I'm just mentioning it as a challenge I think we're starting to really dig into now, is the problem of too much interest in the project is in some sense what the problem is. Another problem is the problem of giving credit where credit is due. So this is all of the people we have to thank for Astropy, right? This is now 120 some people. And it's very easy to get lost in this list, right? You don't want it to be such that if you contribute, it doesn't mean anything because there's 1,000 other contributors, right? We want to give every one of these people credit for having provided a real contribution, and that just gets harder as more people are providing contributions. And more critically, in my mind, is the problem of how this translates into jobs, right? Because in my view, we're facing a possibly very dangerous brain drain in our field, right? Especially with the advent of something that has a name called data science, that all of us know that we can probably walk out the door today and make a lot more money doing data science, right? And that's always been true to a certain extent, but it's much more pressing now because it has this name, and there's a lot more development of these sorts of skills, right? If we're using Python, that's something you actually use in industry. And we need to figure out how we can hold on to people like all of us in this room and provide them with permanent or at least close to permanent jobs that can actually let them stay and do this sort of work. So I don't obviously have the solution. I just want to talk about a couple categories, right? There's a question of, is the solution within the current system? There was a paper we published in ANA that's got people's names on it, so they get citations, right? That's within the means of the current system. We'll probably be publishing more, probably in the next year we'll probably have another one. Another thing that I've found some success with is thinking of us as sort of instrumentation people, just electronic instrumentation or software instrumentation. That gives a lot of traction, it turns out. If you tell people it's the same idea as instrumentation just with software, a lot of people who are otherwise like, oh, why should we deal with these software people, are all of a sudden, oh yeah, right, that is important. On the other hand, it might be we need to do something much more drastic to deal with this problem of giving people in non-traditional software roles permanent academic jobs. Maybe we need to formalize some system of altmetrics, that is, other ways of considering what value is in academia, having new tracks for different kinds of jobs, right? Actually hiring people to be software people, but still considering them part of academia. And maybe we just have to accept that there are permanent soft money positions and that's where we should put software people. That I don't know if that's within the current system or more drastic, really, but that might be the case. And this is probably something that much more about it should come in an unconference session. I'm almost done. I want to end on a high note, though, rather than ending on a low note. So I want to emphasize now what I see as ways of measuring the impact of Astropy. So the first place to look is the paper we published, right? Because that's the way we're used to measuring impact in academia. It's gotten something like 100 citations in 1 year, basically, which is a really good rate for a software paper, right? It's maybe not a great rate for a super influential standard science paper, but it's a really good rate for a software paper. Now here, I think this is just funny, actually. This is the number, according to PyPy, this is how many downloads Astropy gets per month. 67,000. That's right. There are more people downloading PyPy or downloading Astropy every month than there are astronomers in the entire world. That seems very reasonable, right? No, there's something weird with how it keeps track of downloads. But what I've been able to find on the internets is that if you divide this by 10 or 100, it's much more reasonable. So that's actually quite substantial still, right? That's like 1,000 downloads per month. The final thing that I think is perhaps the most relevant is the number of people or number of visits to the documentation site, right? So that's what I'm showing you here. Shows some of those same interesting blips that we heard earlier this morning about Archiver, right? We can see the holidays very clearly. But the point is it's going up, and the last time we looked, right after the 1.0 release, there were 4,000 people looking at the documentation every week. Or at least 4,000 different views of the documentation every week. So that suggests a lot of people, even outside this room, are actually using it to do something, hopefully science. And I'll leave you because I interact a lot with people who do simulations. I know I have to leave you with a video, otherwise you won't be interested in the talk at all. So this is
So this is Astropy's development. So every little node is a file, and all the little weird blobby things that are moving around are individual people committing to the project. So you can just be mesmerized by that. Thank you.
We don't have a lot of time for questions. We can maybe have 3 quick ones if you keep it short, and then the rest we do need a conference session, I gather. Any quick comments or questions?
So somebody's starting to use Astropy with database things like Postgres and all these kind of things. Have you thought about interfaces between those two things? It seems to be fairly straightforward, but it might be a nice little thing.
There's been some talk about this, especially sort of on the table side, right? That it makes sense to connect tables to databases. On the other side of sort of accessing databases, I think what has ended up happening, again, this is organically in sort of a grassroots sense, but I think what has ended up happening is a lot of that has gone into AstroQuery, which we're going to hear about sometime tomorrow, okay. And right, so that's sort of the tool now that we expect people to use to access sources of data online, and then turn them into some sort of Astropy format, right?
There's a new tool coming out of Continuum Analytics, I'm blanking on the name, but it's kind of the all-purpose data interfacer, and I've been thinking about using that as a way of connecting the Astropy table to various other